All right. You know what? Let me get the lights real quick. That's much better. Okay. All right.
Do you want the slide advance?
Yeah, I'm good. Thanks. So I don't know if it's appropriate to thank your own company where you work and you're hosting it, but I'm going to do it anyway because provided the food and the drinks and the space and all that. So especially thanks to everybody who helped set up. That's Jared, Mo, Rob. Thank you. Appreciate it. And thank you all for coming out here. So that's slide number 2. Thank you for coming. I know that you're taking time out of your night and whatever other activities you do to kind of listen to us talk and learn about technology. So appreciate your time and thanks for coming out. So this is only our 3rd meetup of this group. So we're in our infancy. And so it's awesome to still keep having a great turnout. So thanks everybody for coming. But we still need your help to make this successful. So first thing you already did, you showed up. So that's part number 1. Awesome. Thank you everybody for showing up and supporting the speakers because people are, I know at least Joe's practicing for KubeCon, so you're getting to hear a KubeCon talk early. Are you giving this talk at KubeCon?
I'm not.
Okay. Well, I don't know why not. You should have. Are you giving another talk at KubeCon?
I'm waitlisted currently, but we have like 5 or 6, or maybe 4 or 5 different talks from our company. So I'm sure that
so
factors into it.
You may get to just hang out like me, which is actually kind of relaxing. All right, fair enough.
I'm not opposed to.
Yeah.
I can learn something new.
Yeah. So this is a great place to support people in the community and have them give presentations. And if you're interested in presenting, I'll get to that in a minute. Please let me know. Which is number 2, volunteer to speak. That's the best way you can help out. We'd love to create like kind of a bigger backlog of speakers coming up in the coming months. We're kind of ambitious in trying to keep to 2 speakers a month. That's kind of a lot in kind of I would say the Kubernetes community is somewhat small, but growing bigger. So if we could keep it to 2 a month, that would be awesome. If we have to go to 1, that's okay too, but it'd be great to keep 2. And then the other way you can support us is feed us and or host us, kind of like this, like give us food and drink, or if you've got a meeting space, it's always great marketing for your company. Invite everybody to your company you want to talk about Kubernetes work you're doing. Capital One hosted us last month, so thank you to you guys. I think that's also great to show the cool work that you're doing at the place you work and recruit new teammates or team members. So that's a great way to do it. And then the last way, and I don't know if enough people talk about this, but you can suggest other things that we can do in this group. So even though Joe and I don't know if you know Joe's the co-host here. I didn't even introduce myself in the same time, for those who haven't met me. I'm really bad at that sometimes. But the other thing you can do is suggest other ways for us to meet. This is all of our groups. This isn't my group or Joe's group or Otomo's group. This is just a group of people who like this technology. So if there's something you want to do, like you want to do a hackathon, or you want to just work on a cool code project, like we're really working on this little guy. Sorry, you guys are not invited to that. That's just a company thing. But if you want to provide some Raspberry Pis and build a giant cluster, I'm all in for that. But anything you can think of, like if you want to do something different, or your company wants to do something and has an idea, I'm happy to help coordinate that in any way that I can. I mean, this is all about learning, and that's why we do it, because we all think this is cool. I hope that's why you're here. So we do this every time. Most people are really looking to hire a lot of new people to work on this technology, and it's a new technology. So we have an opportunity every time for you to raise your hand and talk about any job openings you may have where you work, or, which is extremely rare, one second, which is extremely rare, but we did have one last time. If you are looking for a job and your employer is not here, and no one else from your employer is here, you'd be surprised. You know, you gotta be careful with that kind of stuff. But if you are the only person from your employer here and no one else here is gonna rat you out, you can raise your hand and say that you were looking for a job. And it only worked last time because the guy was fresh out of college and he didn't have to do it. So yeah, feel free, go ahead.
So hi, my name is Lacey. I'm with SG2 Recruiting. We're right around the corner. Our largest clients are Red Hat, Decipher, and American Technologies, and we're hiring about, I'd say, 24 to 27 DevOps, continuous integration, automation engineers, anywhere from junior mid-level to senior, and AWS architects. So you know, you shameless plug, and I'll leave some business cards up front. If you or any of your colleagues would like to check out our openings, they're on our website. I'll for you with paper.
Thank you. Awesome. Anybody else?
I can beat that. I was Chapter 1, always looking for great engineers. Contact me as business cards. Thank you.
Are you doing anything cool there?
Sorry.
Are you doing anything cool there?
Bryce is cool.
Oh.
It's just my piece now.
Right, sure.
Fair enough. Fair enough.
We're running a Bryce's on this cluster that is run at Linux right now. Run something fast data pipeline streaming, analytic decision making Flake, bringing on sensor flow models, some of the other recognition in the space. So having quite a lot of fun, not in the services mesh space, but in the kind of streaming pipeline and decision making model space.
Awesome. Are you creating anything that takes a fraction of a cent off each transaction and puts it in your bank account?
I'll have to go out to my Ferrari and find out if what the meter is at right now.
Just what's that? I don't know what you're talking about. I know. You're ruining me. All right. Anybody else? Going on? All right, I'll go. So I work here at Otimo, the office that you're sitting in. We're a smaller consulting firm. We're about 17 people, but growing pretty fast. We have about 9 openings. We do continuous delivery, infrastructure automation, cloud, and containers. We're obviously heavily invested in Kubernetes. We're building this little Pi cluster, so if you come work with us, we'll let you play with it. That's a promise. But you have to come on the weekend, maybe. But yeah, we're looking for really smart people right now. We're a bunch of senior people, really talented across a lot of areas. So if you're looking for some fun colleagues and a cool place to work, this is a good place. That's my only pitch. So upcoming meetups. Whoop, that went too fast. There we go. January 2018. So we need speakers. So we're going to skip December. Trying to skip December, holidays, and all that good stuff. KubeCon, all those things. So we're going to be looking at January, and we need speakers. I think I have 1 or 2 possibly lined up. And but we need more. And so like I said, I'd like to build the backlog out at least, I don't know, 2 to 3 months if possible. So you've got some time. So if you're like, you know what, we're doing some cool stuff now, but I'm not going to be ready to talk about it until February, March, April. It doesn't matter to me. I honestly don't care if it's like July. As long as I can pencil you in and start to fill in those slots so that we can get people lined up, that makes mine and Joe's job like 100 times easier, because then we don't have to go chasing people or sending out emails and all that kind of stuff, because I know you guys already get lots of fun emails. So like I said, starting January, this is the way to contact us. So Twitter for both of us, he's at Caffeine Present, or at nova-kubernetes, which is this meetup. And then also, if you don't do the tweeting, you can go to the meetup page, and it says contact organizers right there. All right, with that, I'm gonna get out of the way. We have 2 talks tonight, so if you can stay for both, that would be awesome. First is gonna be Joe Thompson, and then Cody McCain. So please welcome Joe. Do you need my HDMI plug?
No, I'm actually joined the Hangout. So, or actually, yeah, I do need it.
Do you need the USB-C one?
No, I have HDMI on this. So you got the port. Where's? I just have to find where the port is. There it is. Okay. I think I'm gonna move this guy over here so he doesn't. Yeah. Right back. Thanks, kids. Tell you one thing real quick. List. Okay. All right. So I've got that, and let me share my screen. What's that? Let's see. I guess I should share from this. Mirror, yeah, I should. I'd use the mirror and then share. That's what I need to do.
You do it from the Hangout page itself.
I need to mirror my display first. Yeah. Okay. So let's see. Changes. All right.
So I'm still seeing, I'm not seeing your.
Yeah, I'm joined to the Hangout, but I need to share my screen. Okay, so let me go back up here.
Left-hand side, left-hand side.
There's a second thing down.
Yeah.
Okay.
Screen share. Your entire screen. Share. Okay, now let's see what we got here. Give me 1 second. I'm just trying to find something there. All right. Back up. I had Helm list.
Oh, there we go.
Oh, there we go. So that was a get po. There we go. Exasperate the wasp. All right. Copy.
Although I just saw you streaming and recording, so don't say anything you don't want reserved for.
All right. We'll see if my demos come up later. They were working 10 minutes ago, and now I seem to have got my cluster wedged up. But those of you who are here are somewhat privileged because you're actually going to get to see probably a longer version of this than I'll be able to deliver to KubeCon. I only have 35 minutes there. Here I have 45 minutes. So you will get to ask more questions and probably, if my demos come out better, see more demos. So, let me give you the title. This is the basics of debugging your Kubernetes application deployment. So a little bit of debugging the cluster, a lot of debugging the applications, and just enough of both to get you into it so that you can kind of get a toehold in and see where you need to look next. A little bit about me. Been in IT since I started helping out with the computers in my high school back in the 90s. I worked previously for CoreOS, before that Red Hat, before that way back Electronic Arts, a whole bunch of others in between and before those. Currently, I'm a senior consultant for Otimo in the container practice. My blood type is caffeine positive, hence the Twitter handle. And there's all my contact info right there. First thoughts. So this is kind of getting into the right mindset to do debugging. I saw Brad Giesemann do something like this for his Kubernetes hacking presentation about a couple of weeks ago. It struck me that it was a useful thing to open this with. None of what we're about to talk about is rocket science. Most of it's not even really anything new. You've done all this kind of stuff before. We're just probing the state and the outputs of the system to try and figure out what's wrong with it. So, it starts off looking like a black box, but as you start probing into it and picking it apart, you're going to turn that black box into a system that you can actually see and understand. The new things that we're going to talk about are some of the tools and some of the pieces that you're going to probe with. So, and that right there is a picture of the logbook from the moth that was found in a relay in one of the first computers in 1945. They had already had the term debugging by then. This was the first actual bug found. But that was the same thing back then that we're talking about now. Looking at the system, looking at the state of it, running some tests on it, you can see it started multi-adder test. And then they found them off in the relay, which was causing that test to go wrong. So nothing new under the sun. So, you wake up at 3 o'clock in the morning, the page is going off, you're in the data center, things are flashing red, your application deployment just failed. So everybody's stressed out. What's the first thing you do? Well, the first thing you do is what they tell you to do if the oxygen masks drop down on the plane. Put the mask over your nose and mouth and breathe normally. Don't panic. Find a little book of calm. Anybody, any IT crowd fans here? No? Nobody else has seen that? Oh, you've seen it. Okay, there you go. Episode 1. First thing he does. Assorted other advice from classic works of fiction. Fear is the mind killer if you're a Dune fan, that kind of thing. Now let's fix it. First thing you have to do is gather info. Well, what info are you going to gather? That's what we're going to talk about. Then after you've gathered your info, you're going to form a plan, you're going to test it, and you're going to execute it. So some of the tools and techniques here. First steps. You want to get the lay of the land. You want to look at your cluster. Now, if you can do this, your cluster may be in or your application may be in such a broken state that you can't even do this, in which case you're going to be SSHing here, there, and everywhere. But the first step, if your cluster is relatively healthy and you're just trying to debug an application itself that's going wrong, is do a kubectl get. Look at nodes, look at pods, look at services. You can do a get all, and it'll just give you everything. It'll give you the list of every resource that it knows about in that cluster of every type. You might want to throw in a -- all namespaces there so that you can get everything everywhere in the cluster. You see anything that looks suspicious there? Do a kubectl describe. Throw a -o YAML at it, because that'll give you the actual manifest style format of what you're looking at. Again, you're looking at nodes, you're looking at pods, you're looking at services. You might be looking at service accounts, cluster role bindings, persistent volume claims, whatever looks fishy. Sometimes you'll spot the issue right there. You'll go, oh, I have a pod that's crashing. Oh yeah, I forgot to put the stupid pull secret into the cluster, so of course it can't pull my container from my private registry because I forgot to tell it how. And then you'll go, okay, I'll fix that. I'll put the pull secret in. I'll change the deployment to use the pull secret, or whatever the case may be. Now, after you've done that, let's talk about logs. Everybody's favorite topic, logs, looking at them, grepping through them, aggregating them. We're not going to talk about log aggregation, but we are going to talk about what logs you need to look at, what you need to look for. So the first thing you can do is you can do a kubectl get events. And there's a bunch of variations here. Events are actually a resource in the cluster. They're a resource that sometimes doesn't stick around. If it's been a while since events, like I just did a kubectl get events on my cluster, and I only saw one event line because everything else had kind of expired out. That it had been that long since I worked with my cluster. I think it said it had been 6 days. In fact, that's the one thing that I saw there. It was a persistent volume claim error. So if you see something like that in kubectl get events, again, you know exactly what's gone wrong. You need to go fix your persistent volume claims. Or it may be a container pull error that you'll see. Or maybe a container startup error. The event may tell you everything you need to know to fix the issue. You can do a kubectl logs. You can do a log from a container in a pod. If the pod only has one container, you just have to give the pod name. If it has multiple containers, you have to give it -c, and then the name of the container that you want the logs from. This looks uglier than it is, because this one is giving you error collecting weave status backing off. That looks bad. In this case, I don't care about that because my cluster doesn't have weave installed. What I do care about is that last line there. The get sock opt connection refused. Well, actually, no, I don't care about that. I care about the line that was after that I forgot to copy and paste, which was that it was trying to post a report to the weave scope front end, and it was unable to do it. So that would be what I would actually be concerned about. Those are typically, here you see there's actually an indication this is info, this is info, this is a warning. The one that I was looking for had error in front of it, or actually ERRO, since they truncated everything to 4 characters. But either way, you're going to see things in the pod logs if your application actually logs things. And we'll talk a little bit about that later. Oh, yeah? Okay, great. Container logs. Now, let's say your cluster is really borked up. You've got really bad cluster issues. You can't get, kubectl is just not working for you. Or your pods are not accessible. Something has gone wrong and you can't do a kubectl logs. Well, if all else fails, you can SSH to the host and do it with the Docker runtime or the Rocket runtime or the CRI runtime, whatever it is that you're doing there. Sometimes those things are automatically configured to forward everything to the system logs. So it may be easier to do like a journal control or a syslog, look through the syslog directory. And like I said, you can usually get that kind of info from kubectl, but if you have really bad issues, you may not be able to do that. You may have to go on the host directly and look through the container runtime logs. Debugging container. Now, this is not a verb. This is an adjective here. I use debugging containers every now and then. When you've got a really bad issue, you can actually SSH to the host, and you can run a new container in an existing container's namespace. You can attach it to that container's networking, file system, host name view, whatever it is that you're trying to debug, and you can, attach a BusyBox container or even a full OS container like Fedora. If anybody here has worked with CoreOS and run the toolbox command, that's what toolbox does. Toolbox just downloads the Fedora container by default and runs it with the host namespace. So you can debug things. But you can also run the toolbox container at a specific namespace so that you can see what another container on the host sees. Why do you need to do that? If you have one of those applications that doesn't provide good logs. This is kind of your Hail Mary pass of, okay, I don't have any logs. I don't have any events that are telling me what's going on. I want to get on there and look around and do something and run some tests and see if I can figure it out even in the absence of information. So at least you can figure out, you can get into the environment and look around and go, oh, we don't have what we need in resolve.conf, so of course it can't resolve any host names. Or, oh, something is blocking access on port 80 to this other host, so of course it can't post its reports up. You might also have to do that if the host has issues. And if it's a CoreOS host and doesn't have the usual tools, again, like I said, toolbox or just running a container but manually can be safer than quicker than trying to install things permanently on the host. What are we looking for? Cluster networking issues. I put this number 1 because it's the number 1 problem that people come into the Kubernetes Slack channels and ask. They go, none of my nodes are ready. Why are none of my nodes ready? I did, kubeadm. I did a kubeadm init. I did a kubeadm join. My nodes are joined. Everything was successful. All the exit codes are 0, but I can't deploy anything. Nothing starts up. What's going on? Well, they forgot to deploy any kind of container network. So, specifically with kubeadm, you don't get a container network by default when you set up the cluster. You have to pick one and deploy it yourself afterward. That's actually something that I've discussed on Twitter with some of the Kubernetes guys, and their take on it is they specifically don't want to create a reasonable default there because they don't want that to become what everybody does just by default. They want everybody to make a choice of what cluster network they want. They want everybody to look at it and decide what is the right thing for them. But at the same time, as far as they've backed off from being opinionated there, it's actually causing problems for people. So did you deploy a cluster network is the first thing to ask yourself if you have all your nodes are unready. If you did do that step, are the pods for it starting? You'll see, if you deploy Flannel and your Flannel pods aren't starting, they'll show up, with whatever their error status is when you do a kubectl get po. And then that'll tell you, you can get logs, you can get events, you can figure out why Flannel's not starting up. If it is starting up, are the expected interfaces showing up on the host? You should see some things happen. And if not, you have some more stuff to debug. I don't really dig way down into this because once you start getting down into that networking hole, you go about as far down into it as you want. The other thing, and this isn't something I see often, but I have seen it, is our firewalls preventing the packets getting between hosts. This is, again, is especially something I've seen with Flannel because the default Flannel backend is UDP. And so if your firewall is on, it's probably going to block UDP by default if it's a Red Hat system, so Flannel doesn't work. Pod startup issues. By far the most common pod startup issue is pods don't get scheduled at all. Sometimes that makes it harder to debug because if a pod's not even getting scheduled, you don't have container logs, you don't have pod logs, you don't have events. Well, you do have events. You have a failed scheduling event. So that's where you sometimes will see a failed scheduling event. It'll tell you why it didn't schedule, and you'll go, oh, that host doesn't have enough memory, or that host ran out of disk space, or whatever the case may be. If they're getting scheduled, are they starting? If they're not starting, why aren't they starting? Are they starting, but are they crashing right away, or are they crashing after a while? This is where your pod logs will really come in handy because they will tell you things like you have a container pull issue. Like you forgot to put the pull secret in, or You know, you have a private host that this cluster can't get to because it's somewhere else on your network and you don't have routing to that particular piece of your internal network. You might have an init container that's failing, and so the pod never actually runs. You could have a pod that is running, but its probes are failing, so it's never marked as ready. You could have the liveness probe fail, in which case eventually the pod will get killed and rescheduled. You could just plain be running out of resources. I was talking with Dalton Hubble, who's one of the guys at CoreOS the other day. He is actually running into issues on his cluster because the API server in versions 1.8 and 1.8.1 has a memory leak. And so his API server would run for a few hours and then it would eat all the memory on the system. So then the API server pod would fail. So what he actually started doing and they did patch that, the patch for that came out in 1.8.2. What he ended up having to do was modify his API server pod definition to say, I think he put a limit on it of about 400 megs. So it would leak memory up to 400 megs, and then it would automatically be killed and respawned by Kubernetes. So every couple hours, he would see a brief little blip, and then things would soldier on as normal. But you know, these are probably pod startup issues are the main thing that people have issues with. Service discovery. People create a service, and then they can't access it, or they can't access what's behind it more accurately, because they type out the service name, or they put the service in the wrong namespace, or sometimes kubedns is not running. I've actually got a demo, not really a demo, more of a puzzler for the people at KubeCon. An issue that I ran into the very first time that I did a customer deployment with straight up bootkube instead of, you know, like Tectonic or something. I had an issue where kubedns was not coming up, and it turned out to be a networking issue that was causing kubedns not to be able to start up. Well, kubedns not starting up doesn't mean you can't deploy things, but it means that anything that uses DNS-based service discovery will fail. So, for example, the guestbook would deploy, all the pods would come up, but it wouldn't actually work. So things like that can be an issue, and what you do is, you, like I said, you go back and you look at the pod logs for the pieces that are accessing other pieces through the service, and it says, I can't get to that service name. And then you go, well, is kubedns working? Let me start up a BusyBox pod and run some DNS queries. And then you go, no, it's not working. And then you look at the kubedns pod and it says, no, it's not healthy. I think in that case, what I saw was that it was just sitting there and pending forever. The other problem, do your services have endpoints? Services don't do anything on their own. They just route traffic to something behind them. The something behind them being pods. If there are no pods that match the selector and the service is useless. I mean, yeah, maybe you could, there are reasons that you would do a headless service or a service of like an external name type that doesn't have pods backing it, but that's not what most people are doing. They're trying to expose something in their cluster. So if your service doesn't have any endpoints, you can't access whatever it is that you were trying to access, and you need to figure out why. You know, is the selector in your service wrong, so it's not selecting anything? Did all the pods behind it die? All the pods behind it unhealthy for some reason? Again, you're going to be looking at the service. You're going to see where the endpoints are supposed to be. You're going to go look at the logs for the endpoints. Access control issues. These are cropping up more and more and more because role-based access control got turned on by default in 1.6. Network policy is now out of beta. There's not any default network policies installed, but it's now out of beta in 1.8, and people are playing around with it, and just like people playing around with IP tables, it's easy to shoot yourself in the foot. So the biggest question you have to ask yourself is, if something is not able to access something else, is it because I put a network policy in place that's causing that not to be able to be accessed? If you delete all your network policies, do things start working again? You know, it's the brute force method. It's like turning IP tables off completely to see if you have a problem with your IP tables rules, but sometimes that's what you need to do. I mentioned role-based access control. There's a lot of things out there, and more, that are using the Kubernetes API itself, either to monitor Kubernetes or manage Kubernetes or discover pieces of themselves. If you deploy Elasticsearch, one of the plugins for Elasticsearch for the masters to discover each other is a Kubernetes backend. And what it does is it actually hits the API server and says, tell me about all the other Elasticsearch master pods that are out there. Well, if RBAC is on, but you haven't given the service account associated with Elasticsearch permission to access the API, that doesn't work. Your master pods will all start up and they'll just sit there trying to ping each other, but not knowing who to ping or where the other pods are. And they'll just sit there forever, constantly recycling, until you finally do that one step of creating a cluster role binding to give them the permissions they need, and then everything resolves within 10 seconds. I was helping somebody out with that the other day on one of the Slack channels. He had issues with the Elasticsearch Helm chart that was using that Kubernetes discovery plugin. And so we sat there and we poked and prodded, and I looked at the logs for the master and I said, hey, this master is using some plugin that I've never seen before. And I went and looked up the plugin and looked at how it worked. And I said, oh, that's what the problem is. If we give it cluster admin permissions, it'll probably work. And sure enough, it did. Again, kind of the brute force approach, but you know, turning off access controls or giving admin access diagnostically at least tells you something. Very occasionally, I'll see people have TLS issues. The certificates are old, they've expired, they're signed by untrusted CA, which if it's a self-signed certificate, you need to trust that certificate as the CA if you want to use it.
How about time skewing?
Time skewing, I see a lot of talk about it. I see a lot of diagnostic stuff that's intended to detect it and prevent it. I've never really seen, I mean, I'm sure they're out there, but none of the systems I've seen have ever had time skew issues because most production systems by default are already syncing to some NTP source anyway. I think by default, like all systems sync to pool.ntp.redhat.com or something. There's an alias that they use for that. So if you have time sync turned on and all your nodes are syncing to a similar external source, they're probably not going to skew that far. But yeah, that's a thing that can happen. And you'll usually see that if you do your TLS diagnostics. Yeah, you're going to have to bust out OpenSSL or something, GNU TLS if that's what you like, and debug that TLS issue. Again, that's not something I really dive into because there's a lot of ways that can go wrong, but it does happen. The other thing that happens is simply the client certificate that you have doesn't have the permissions to do what you want to do. Most cluster installers generate an admin certificate, but then some people go in and they generate a user certificate with limited permissions. And if you happen to be using the user certificate when you think you're admin, things are going to fail. Preventive and remedial measures. So this is, this is starting to get more into the philosophy of what you should be doing to prevent these kind of things in the first place. And then, of course, how to fix them or how to detect them after the fact once you deploy. So talking about application design. Did I talk about logs before? I feel like I talked about logs before. We're going to talk about logs again. Because the number one thing that I see that's frustrating as an admin is applications that don't log enough info. They don't tell me what I need to know. They just throw an error like error, connection refused. Connection to what? On what port? When? How many times did you retry? Does your application log in? Now, obviously, this only works for applications that you design or that you're writing. But I feel like at least some of the people in here are writing applications, and this is a thing that some people need to hear. Not anybody in this room, I'm sure. Does your application log enough? Are you sure it logs enough? Go ahead and write some more detailed logs anyway. If you look at the kubectl logs, it will give you logs up to, I think, level 8. And if you, in the future, if you just want to say, give me all the logs that you have for anything ever, you can just say log level 99. And that'll cover you. You don't have to worry about later if they introduce a log level 9 or 10 or whatever. It's just you say B99 and it'll give you whatever it's got.
A suggestion that Hey, one of the things developers should consider is don't just provide your code to operations or test, also provide a monitoring dashboard, meaning that have a dashboard that your monitoring system ingests that already has panels in it with queries in them so that somebody else can look at that dashboard and know if something's wrong with your service. So it's very easy for developers to say, here's my code, and now it's your problem. If instead they along with their new service, include a dashboard that has built-in monitoring ability that's already tailored to their application. It makes it 100 times easier for somebody later to look at it and not have to call them in the middle of the night saying, hey, we're getting this log message, what does it mean?
And that leads into my next point, which is, does your application have diagnostic tools? I mean, probably half the tools that you use as a sysadmin are diagnostic tools. And it's lookups, you know, even basic things like LS, you're looking at the file system going, are the files that I expect to be there? Do you have documentation for your diagnostic tools? There's nothing more frustrating than to have a tool whose name suggests that it's exactly what you need, but it doesn't give you any help output when you run it without arguments. It doesn't have a man page. It doesn't have an info page. Nobody's even written up a little thing in Notepad and passed it around, or a sticky note in the data center. Document your tools. Have tools that need documenting, and then document them. Can your application roll back from failure? If you start to deploy a new version and it fails, can you roll back, or have you already made changes that are not easy to reverse, or that require a long, involved manual process to reverse? Application rollbacks that's one of the things that I saw when I was at CoreOS. The Quay team was always very concerned about whether or not, if somebody started to deploy a new version of Quay and weren't able to for whatever reason, could they roll back to the previous version easily? Once or twice, they would say, no, you can't roll back. This is a database schema change. Once you've gone forward, you can't ever go back beyond that point without restoring from backup. So take a database backup before you do this. And then, of course, you know, kind of a sub-point to that, I really should have indented under it instead of having it be a separate point, is how safe is your data and state in case of failure? And that's not a rollback issue. That's my app was running and then it crashed. Can I just start the app back up? Will it pick up where it left off? Will it lose data or lose state? And if so, how much and in what way? Pre-deployment. Test environments are not optional. I know everybody here has said we need a test environment and been told by their management we don't have the money. You don't have the money not to have a test environment. Yeah. Well, let me put it this way. You have the money not to have a test environment right up until something happens that wouldn't have happened if you'd had one. I've been there. I asked for testing space to do testing on an application. It was actually an RPM update on a RHEL 5 system. And I said, we need to do a test of this before we just go deploy this thing. And they said, well, we don't have a test environment. You're just going to have to use your best judgment. So I used my best judgment, and it turned out that there was an architecture issue. Some of the systems were 32-bit, which we didn't know because it wasn't documented anywhere. And so when we deployed 64-bit RPMs to those systems, not only did it not work, it actually broke some things that were there. That was a long night. So yeah, you need a test environment. For lack of a test environment that probably would have cost them a couple grand, they had 10 people at, you know, however much a consultant is, $200 an hour, working all night. I mean, when you add it up, they could have bought a test environment and run it for a year on what they spent on our wasted time. Factor out redundancy in your deployments. Repeating yourself is error prone. It's like a game of telephone. You go, oh, was the application name XYZ123 or was it 123XYZ? Should we just guess? No, we shouldn't guess. It takes time to go back and figure out what did you say before. If you're going to say the same thing, say it once. Refer back to it. I'll talk a little bit about that in an upcoming slide here. But then more importantly is don't just have both of these as principles that everybody pays lip service to. Make sure that everybody is actually doing these things. And the way you do that is by making sure that in your environment, not only are both of those things supported, they should be the easy thing to do. It should be hard to repeat yourself. It should be hard to not put things through test. Somebody should have to actually go to people and say, I want to deploy this straight to production. And, you know, get a key and get somebody else to come to the missile silo and turn the key at the same time. Make it as difficult as you can without actually making people so mad that they fire you. Post-deployment. Most of what you should do post-deployment looks a lot like a standard CI/CD pipeline. Do validation tests. Watch things for a while. Make sure things come up and talk to each other properly. Every now and then, let the chaos monkey loose. I don't know if anybody here has ever heard of the Netflix chaos monkey. Yeah. So Netflix has an ironclad principle that a thing should be able to die without anybody on the user end noticing. So they actually have a chaos monkey procedure where it could be that an application process gets killed. I've heard that sometimes they actually will literally go into the data center, walk up to a server, and just yank the power cable out.
They shut down entire regions.
Well, they do that too. That's an orderly shutdown. I'm always a big fan of the, do you trust your system enough to just yank the power cable out and take a chance on disk failure and all kinds of other stuff? They do. They do as a matter of policy. I don't know that I've ever heard of the chaos monkey taking anything down. They've had outages, but after they have outages, they go back and the first thing they look for is why did it happen and how do we stop that outage from happening again? A few words about Helm charts. What is Helm? What is a chart? What is a Helm chart? Helm is a packaging and template system for Kubernetes deployments. This project, because it is involved in application deployment, has, it was started by people who wanted to do their deployments repeatably and efficiently. And so they came at it from an application development perspective, and they put in some of these principles like don't repeat yourself. Don't repeat the same info. Have a variable that everything references, or have a template parameter that everything references instead of repeating the same string 5 times in a template. Don't reinvent every wheel. It's not exactly an official principle of the project, but you will see people ask a lot of the time if you're saying, hey, I'm writing a chart for this and I want to depend on this other chart that I'm writing, they'll go, there's already a chart for that dependency bottom. Why aren't you using that? There may be a valid reason why you're not. And if the reason why you're not is that chart doesn't work for me in my configuration, they're going to go, well, could you submit a pull request? Because if you're needing to do something that the chart doesn't already do, somebody else probably is too. And this is a more recent one. They've added the ability to do tests. And so now they are actually implementing a policy of every Helm chart package has to have a built-in test. So, like I'm writing one, it's actually in the PR process right now, and the test for it is just a basic, can you hit the URL for the app front end? And so I spin up a container, I do a curl in the container, and if the curl returns a 200 OK status, then that test passed. That's the only test I do. But I mean, if I can hit the container, through the service, then that means that at least some minimal subset of things came up properly. Where you can get more help, because I didn't really tell you that much here, at least not that much that you didn't already know, if you think about it. If you run into issues and you're going, I don't know what that error means and I can't find it in the documentation, because although I won't say this at KubeCon, the Kubernetes documentation is, yeah, it is. It exists.
It got better.
It got better. It got better. The bar for that was pretty low, but it did manage to clear the bar. And it is getting better, and there are some things that I refer to constantly, because there's little bits that you go, oh, I need to bookmark that because I'm going to use that a lot. So some of the docs that I look at are these API docs. The API reference will tell you everything you ever need to know about how to write a manifest. It gives you the entire tree of, for example, a deployment. And it will say a deployment is made up of X, Y, and Z, and then a pod spec. And pod spec will be linked, and you click on it, and it tells you all the things that go into a pod spec. And pod spec will have a container spec, and you click on container spec, and it gives you X, Y, and Z of what is a container spec. So it actually gives you a very nice view of resources and how to write them, and you can look at it and get an idea of how you may have written your resources wrong. There's also this tasks page. I wanted to link directly to the monitor, log, and debug category under it, but even though it looks clickable in the doc site, it's not actually a clickable link. But the main tasks page there's a sidebar. Down under the sidebar, there's this monitor, log, and debug entry, and then it's actually got a bunch of things, but these are the two that you probably are going to want to bookmark and refer to a lot. One is troubleshooting your clusters. The other is troubleshooting your apps.
One other thing you might mention there
Uh-huh.
is kubectl has a built-in explain command, and It can explain all the different types of resources.
When did that come in? Because I feel like that wasn't there when I started working with it.
I don't know the exact date that comes in.
That
But it's,
came 1.4 or something.
yeah, it's been
Okay.
there for a while. But
Mhm.
the nice thing about it is, if you're worried about if you're looking at out-of-date documentation or not, as long as your kubectl command line client is up to date, you're going to get the latest and greatest information about the resources you're describing.
Yeah, and that's the other thing I do a lot is I just go kubectl, enter, and let it tell me all the subcommands it knows. And so on down the tree until I figured out. I was, like I said, I was debugging that RBAC issue with that guy on the Elasticsearch chart the other day, and that's what I did. I said, kubectl create. It told me all the things it can create. I said, kubectl create cluster role binding. It told me all the arguments for cluster role binding, and that was all I did. I didn't have to go look at the API documentation or anything. I just did it all straight from kubectl. Kubernetes Slack, kubernetes.slack.com. The channels that you probably are going to want to start with, Kubernetes Novice, Kubernetes users. They actually have a note at the top of the Novice page right now. The topic says, if you don't get an answer, it may not be a Novice question. Go check over in Kubernetes users. In practice, I see people use those two channels fairly interchangeably. And I think it's because a lot of people just don't know if what they have is a Novice question or not. There are times that I go into Kubernetes Novice and I go, I don't know if this is a Novice question, but I saw this. What does it mean? Demos. I'm going to skip the demo for the moment and go to the end of my slide because I don't know if my demo cluster has purged the failed Helm deployment that I threw into it yet. Final thoughts. Oh yeah, I forgot to tell you how to fix anything, didn't I? Well, now that you've spent all the time gathering info, you probably figured out what's going wrong. Kubernetes is a declarative system. You don't tell it how to do things. You tell it where you want things to end up. So 9 times out of 10, when you figure out what the problem is, you can just go fix it in the manifest, which, by the way, you can get from Kubernetes itself. If you don't happen to have a copy of it laying around in a file, you can say kubectl describe or kubectl get-o YAML. It'll give you the YAML format manifest. There are some things that you'll have to edit out, like status entries, but you can use that as a template for the changes you need to make. You know, you messed up a container tag, whatever the case may be. You fix it in the manifest. You do a kubectl apply-f. Kubernetes will figure out what it needs doing. Deployment, it'll automatically roll the pods in that deployment for you. There are things you may have to clean up yourself. Don't forget to fix your manifests and fix your state before you go clean things up, because I've seen people, they only do it once, but I've seen people do something like, well, I have this error in my deployment, so what I want to do is kill all my deployment pods and then fix the deployment. No, that's backwards. You have to fix the deployment first, and then Kubernetes will fix the pods for you, because it'll say, oh, something changed. These pods are out of date. I need to roll these deployment pods so that things are up to date. Don't make work for yourself. Let the system do what the system is designed to do. We just scratched the surface here. I talked for, what, about, what would you say, 20, 25 minutes? And I really didn't, like I said, I didn't tell you anything you didn't already know. I went over some new tools. I went over some techniques that may be new to some of you. I talked a little bit of philosophy about application design. There's a lot more out there. There's a lot more tools out there. There's new tools coming up every day. And I can't keep track of it. There's thousands of people working on Kubernetes every day. Some of them getting paid to just do that all day long. And they're coming up with all kinds of awesome stuff. I mean, this fella back here is going to tell you all about Calico in a minute. That's something that didn't really exist when I started working with Kubernetes back in the dim, dead days of mid-2015. Was it 2015? I don't think it existed that far back, did it?
I don't think so.
No.
Well, it was already being worked on. I don't think.
Yeah, it hadn't been released yet. Back then, everybody was using flannel because that was the only thing there was to use. A lot of the traditional knowledge that you've all built up over your however many years you've been working in this field is still relevant. Even things you learned before Kubernetes. Does netstat work any differently because it's running in a container? Does TCP dump work any differently because it's running in a container? Not really. You may have a different scope of what it's operating on, but the tool itself is still the same. It's still equally useful as it always was. And that leads into my last point there. You know more than you think you do. Don't be afraid to just go poke around the system, because when you're doing gets and describes and things like that, you're not modifying any piece of the system. You know, you're just saying, tell me what the system looks like now. And again, going back to an earlier point, if you have a test environment, you have a place to test things out before you deploy them to production and see if they actually worked. And a lot of the time you'll find out, oh yeah, I was right. I didn't know if I was right, but I was. Anybody got any questions? Yeah, in the back.
I tried Helm Charts interesting. So I'm assuming you know a little bit about Ansible.
Yeah.
You looked at Ansible, right? So
Previously, yes.
So comparing the two, so using some templates, you know, templating with Jinja, some spec files, you know, using the shell module, to apply that versus Helm Charts. What are your thoughts on that?
I think, so the basic idea of templating things in that fashion is common to both of those tools. You can do Kubernetes manifest deployments templated through Ansible, just like you can through Helm. Where I think Helm has an advantage as a tool, and you can easily use Helm with your Ansible playbooks. That's something a lot of people do. Where I think Helm has an advantage over just using straight Ansible is Helm is actually designed to work with Kubernetes. So it does things like, when you deploy, what it actually does is it runs your manifests that it renders through kubectl to validate them before it actually deploys them. And if the validation fails, it'll throw an error back at you. Ansible doesn't know enough about Kubernetes to do that unless somebody's written a plugin to do that. Which, you know, I don't know, is there a Helm plugin for Ansible? Yeah, so I mean, you could easily have an Ansible Helm install, whatever.
It's also give you like this idea of an instance of everything that you deploy, right? So if you want to cookie cutter something, like say you're testing something, and a developer wants to say, I want to deploy my entire platform. Maybe that's a little too broad, but they could deploy a large segment of your platform as a completely separate copy without having to do any magic with namespaces and other things like that, because Helm Charts track everything that's just deployed as a unit and it can be removed as a unit.
Yeah, that's great. Another question on that. So we've experienced some things where kubectl can time out. Is Helm resilient towards that?
Helm is using the same kube config that kubectl uses, like literally. Yeah.
Helm doesn't use the API, it does not use the kubectl. Right. It doesn't use the API that kubectl uses. So
Right, but what I'm saying is it uses the same kube config to figure out where to access the API server and what credentials to use and what the certificates are involved and that kind of thing.
I guess I really like to see Helm Charts. It seems like you can modular developers and test things a lot easier for developers. So one drawback was for us is our API server, kubectl, whatever is getting used right now, right? So they have some retry, use retry statements, and then essentially ping it multiple times to ensure that the apply takes effect. Does Helm have an improvement to that?
So that is a problem with the API server. The API server isn't responding. The API server has metrics of responding. So it's essentially masking the problem. Rather, I will look at the API server. The API server has Prometheus metrics, which specifically says why it's slow. You should probably look at that instead of masking the problem doing a retry. That's my two cents.
Yes, it's very rare. It's maybe less than 1%, but it does happen. I was just wondering if you're like retry.
We actively monitor Kubernetes API server, the Prometheus metrics, which essentially says when it does not respond back, when sometimes it starts throwing warning, we know that's proactive instead of being reactive.
Oh, that's nice.
I would use that as an option. And Helm is atomic too, right?
Yeah.
So if there was an intermediate operation during deployment that failed, it's going to roll everything back. So you do get that. I see what you're saying, though. I think it would be a useful feature to have an internal retry, and there may be. I don't know why that wouldn't be something. All the data guys just joined Microsoft, so we have to check Microsoft to find out what the development roadmap is on. As much as I like Helm,
Helm is a tuning language on a config, which is not good, like which is a hacky way. The Helm team came up with something called Brigade, which is a lot more nicer API based, JavaScript based, which is a lot, again, it's an alpha, but it's a lot more better, though as much as Helm is good.
What's that? All right. So I think I did manage to purge things. So let me show you some of what I'm going to do. Is I'm going to deploy the Weave Scope application. Then I'm going to break that deployment and show you some of the kind of things that you would look for in the log entries. So let's see here. Helm install. Where did I go? Logs. Helm install. I should just do a history. Oh, there we go. Helm install Weave Scope. Okay, so this is a Helm deployment. It just installed the front end. It installed the agents. If I do a kubectl get po, I'll see some of those things. The release name is masked salamander. It does that cutesy little thing that Docker does where it auto-generates names for you using different word lists. Now, right now, if I do a kubectl get service, I can see I have a Weave Scope app service. And then I can do get service Weave Scope app. I can do a get endpoints on Weave Scope app. And I see I have an endpoint. I have one endpoint. Now, if I go in and I delete that deployment, which is called Weave Scope front-end masked salamander app, now, what I would see if I, let's say I was deploying this in two pieces. This is why I recommend Helm, because your Helm chart has both of those pieces for you. You never forget to deploy one piece because they're both there. But if I were deploying this in two pieces and I had forgotten to do the deployment and I created the service and I was expecting the agents to get to that service, they're gonna tell me things like, if I go and look at this agent log here, kubectl logs. See, I have all these errors, and you can see the errors begin right about the time that I deleted that deployment. So everything was pretty much fine right up till I did that delete deployment. Now, I didn't actually save the deployment, but if I had, I could create that deployment. Those endpoints would come back up. So if I were to see something like this, get sock opt connection refused, I would go, well, is my service there? kubectl get service. My service is there. What's wrong with my service? My service, whoops, get service Weave Scope app. Oh, things are slow for some reason. My service has a cluster IP. But then digging a little deeper, I would go kubectl describe service Weave Scope app. I have no endpoints, so it's not passing data through. Why don't I have any endpoints? I would go kubectl get pods. I might do something as simple as this. I know that my pods are all named. What was that name again back there? Masked salamander. So I could grep for masked salamander. And I go, oh, the agents are up. I forgot to deploy the app. That's what the problem is. So then I go deploy the app, everything's fine. My endpoints will come back. That's the one thing I was going to do, although I'm running out of time, I was going to do a demonstration of RBAC. And when I do this for KubeCon, of course, I'll have pre-recorded versions of all these. As a side note, when you're doing demos like this, I haven't had time to actually do the recordings yet, but there's a utility called Askinema. If anybody's ever used it, ASCII. NEMA. And what it does is it records all your keystrokes in a JSON file, and you can play them back. And so you don't have to record this big bulky video of yourself doing whatever. It's just recording JSON text, and you can play it back, and it plays back your terminal session. It's really neat. So with that, I'm going to go ahead and hand things over to our guest from Tigera. Where did he go? Is he over there? Yep. Any last questions before I close this down? Okay. You had your hand up first, I think. Test RBAC issues. Well, usually what you'll see when you're having an RBAC issue is you'll see logs in something that will say that it's having trouble accessing the API server. Now, again, depending on the application, you may have to kind of read between the lines. If the logs are saying it's having an error trying to access 10.3.0.1, 99 clusters out of 100, that's the API server, even if it's not telling you that. Even if the app is not intelligent enough to say, I can't hit the API server.
I liked your idea of the toolbox workload that you deploy. I'd seen that used in unikernel debugging, and I forgot about it. And so thank you for that, because I think that's a great hint. Obviously, you don't want to deploy Nmap and a lot of other like hacking utilities out, but you do want to do them when you're debugging.
Right.
One question was, you had mentioned like the kubectl get events retention. I know we've been burned by that, and it brings up the larger question of some of the defaults that you want to set to do longer retention for the logs when you go into production. I don't know if that's one that you can set, but I'm going to go tonight and research.
I was going to say, I was looking for that earlier because I hit the cluster and it only had the one event for me. And I was like, oh, it's a good thing I hit it today because tomorrow I might not have any events to do. I mean, if you want to generate some events, you can just deploy another deployment or something like that. But what I specifically wanted to show was that failed event. And it was lucky that I caught it when I did. I don't know if you can make it retain things longer. I want to say probably. He probably knows.
Heptio, if you don't know, Heptio is an organization that's with Google guys who are building Kubernetes when it's not a bad. They have a bunch of project where they take your Kubernetes events, there's a deployment that takes them and shoves them out. So essentially, it's a pod that's running on listening to the API server, gets events, and shoves it outside. So essentially, you retain your events. The reason that they use this 3 or 6 months, you start to see a lot of history behind this, and you can figure out how your cluster is behaving, what are the problems that are happening. So you can go look at it. It's an open source project.
It's a Heptio project.
Heptio also has got another phenomenal project called ARC, which backs up your PVs. And so Heptio has got a lot of phenomenal projects.
And of course, the other thing, I mean, going all the way back almost to the beginning of Kubernetes, the standard stack for logging and monitoring now, the base of that stack is the ELK stack. Elasticsearch, Logstash, Kibana. And so you can configure that if you have things pulling the logs out to an external service. You can configure that for whatever retention you want. Last chance on the slides. Of course, that's a QR code that takes you to that URL. You can just take a picture of the URL and type it in later. Any last questions? All right, I think we're good. All right. Plug my stuff. Here's the doodad if you want it. All right. I'm just unplugging my stuff and taking it right over there. Okay. Oh, let me unshare my desktop.
Actually, the camera will. Well, it's recording. The stream is recording.
Screen share.
There's no mic in the room.
Did my screen sharing already stop?
I switched off of it.
Oh, you switched off.
Yeah, I switched back to the camera.
Okay, that's great.
Yeah, if you want to do it that way, if you want to join the hangout, stream right from your machine, whichever way you like. Yeah, okay. Sure.
There we go.
Joe, I'm just going to set this down right here.
Okay, I'm just going to take this over here. Here.
The only advantage of the screen share is if what you're projecting is small text or anything like that.
Sure, I can screen share. Just tell me where the Hangout is.
Give me an email address and I'll send you the link.
Cody@tigera.io. CODY at Tigera, GERA.io.
I will also be hanging around after this if anyone want to ask me.
All right, there's an invite on your way. Let's see if you get that.
Cool.
Send you a second one by email too, just in case. Did you get it?
Yeah.
Right. All you got to do is share and hang out.
Yep.
And then in the upper left, inside here, you pick, or go ahead and go in there. So then you pick what it is you want to share. So if I can pick that guy, and then share your desktop or whatever it is. And then what'll happen is I'll see that in the stream here, and I select the camera view or what's streaming from you. One or the other. So,
Perfect.
and you don't have anything you don't want captured and recording, right?
We're good.
Okay.
Everybody gets the drink or whatever. We'll get started. How about everybody get something to drink and more snacks, and we'll get started here in about 60 seconds. How's that sound? Well, they're doing that.
Oh, you might need to share your desktop again. I'm sorry, I selected something else for a moment. I think it turned it off.
Did it stop the Hangout as well?
No, just stay in the Hangout. You just need to say you want to share your thing again. That's all. So, second one down, that guy right there. Yeah. There you go. Yeah, sorry about that.
No problem. All set. All right, we're going to get started. Everybody's ready to go. My name is Cody McCain. I'm with Tigera. As you can see, I brought my lovely medicine cabinet with me. I apologize for my incessant coughing. I'm recovering from a little bronchitis over the weekend, so if you could just bear with me through this, I'd be really appreciative. Oh, we're not. Oh, I'm not plugged in. My bad. That's just fell on my part. See if this fixes it.
That's another problem you may have with your cluster. Or all your nodes.
You might need to share your desktop again and hang out. Switch back to
If you're not awake now you are, right? So we got that out of the way. So how many in here have heard of Project Calico? I'm just curious. Yes, all right, great. So I work with Tigera. Tigera is the company who originally founded the project, Calico. And I'm actually located up near New York City. I actually live upstate New York. So I jumped on a train at 5 o'clock this morning. So if I say anything that is incoherent, just look past it. we'll look at the logs later and correct that error, as Joe was talking about. So, as I was saying, Tigera is headquartered on the West Coast in San Francisco. That's where the majority of my colleagues are at, and we also have a group in the UK. And I am the sole lone survivor out on the East Coast. And so if you ever want to talk networking or anything else, hit me up, because I don't have any colleagues to talk to. They're all somewhere else. I got my start in Kubernetes about 2.5 years ago. I was beginning to introduce GE Global Research to some of the concepts while I was there. My background is actually in particle physics, and so if you hear a stupid particle physics joke, either pretend we're on the Big Bang Theory or laugh with me. It'll be funny, I promise. But tonight I really want to focus on, I don't have any major whiz-bang demos, okay? I don't think that's important for what this meetup is designed around. I think it's important for you to be able to walk away from this meeting tonight understanding the primitives of actually how networking in a container orchestration system like Kubernetes works. If you can understand the primitives, the basic blocking and tackling, okay, you are all smart people. You can all go read blogs and read the documents. You can hit me up on Twitter, and we can actually work through some interactive stuff. But I really want you to focus on how things work underneath the hood. So we're going to actually get into some kernel stuff. Things that you might think are magic or hand-wavy and mystical, I'm going to demystify tonight, I hope. So here's my plug. See, I have a, kind of like James Bond has a money penny back home, keeping tabs on him. I've got a money penny back in San Francisco wants to know that I'm really here tonight. So here's what I'm going to do. The first 2 people to tweet something about this meeting, mentioning those things right there, I've got a lovely Calico kitten, and I've got a T-shirt that is all yours. So whichever one hits my feed first, if you can include a picture, I'd be appreciative. I got to start in distributed systems early, and this is my distributed system back home. So this is who I leave to go out on the road and teach people about Kubernetes and container networking. And I like to point out that distributed computing is a family affair at my place. So what are we talking about tonight? Before I get into container networking, there's a couple that are new to Kubernetes here, right? Tonight, a couple that haven't done a lot with Kubernetes, maybe? Good. So we're going to talk a little bit about a progression. Joe said something I think is very important. There's nothing new under the sun. All of the things that you've learned over the years, some of us have learned more than others, so we've been around longer than others. Those are all applicable to what we're talking about tonight. But I want you to be able to put on different hats. I don't know what roles that are covered in our audience tonight. I don't know how many are devs. I don't know how many maybe are security managers or deal with operations, deal with compliance and risk. All these people, remember, technology is people, processes, right? Technology. It takes all of these things here and these perspectives to actually be considered to make a functioning system and make it produce the right results. And so the solution utopia is if we can figure out what all these different roles want in a solution, then we can have a better solution. So I want you to not only think as a developer or as an ops guy tonight, think about a compliance guy. Think as a risk guy, okay, or gal. And then I also want us to think about SOA. Everybody knows the term SOA, right? We're still doing SOA. I hate to break it to you. We just call it microservices, guys, but it's SOA. It's a little different. It's a little packaging difference, right? Instead of everything being in a monolith, right, and you've got all these threads talking to each other in the same memory space, right, we've decided we're going to introduce the network. So we're going to bust everything out into its own process. And instead of using in-process communications via API calls, library calls, memory passing, right, that kind of thing, we're going to serialize everything, put it on the wire, and allow it to be connected over the network. It gives us a lot of advantages, right? It allows us to scale out horizontally, right? We can only make so large of a machine, right? At some point, the number of cores you can put on a board is exhausted, or the amount of memory you can put on a board is exhausted, right? So at some point, we have to hit the network with bits and have our distributed coordination occur over multiple machines.
Thus, we do distributed computing, and it's a very complex thing, but if we can think about the principles behind it, I hope that you will find some simplicities in it. We started this way back, right? Who did Corbett in here? Yay, okay, I don't know about that. I did too. ESBs, right? A lot of the concepts we're talking about are still applicable with ESBs. You know, we did API management, and you know, still the same kind of thing, right? We're still doing SOA. We're just calling it all these different things or different ways to package stuff. But what we really want is something that is independently deployable. It has a limited scope, right? We want to be able to test this thing without having to bring in the world. We want a published API. We want strong contracts between things. It helps with testing, right? It helps with making sure that we know when we're done, when we say we're done, because we know what the scope in the contract was. And we want things that are out of process in terms of things that connect over the network, because the network has really served us well as a wonderful interface tool. When we take things out of process and out of runtime languages, now suddenly we can have a polyglot solution. I'm not bound to Java. I'm not bound to Python. I'm not bound to Go any longer, right? I can write my solution using the tools that fit the problem the best, connect all the components together to have a full application or platform or whatever the business driver is requiring. So, SOA today is simply microservices connected over the network. If you're using Kubernetes, this is a Kubernetes meetup, we call those pods. And those pods can have one or more containers, but the idea is the most atomic unit of deployment, the most atomic unit of being able to schedule work is the pod, and every one of those atomic units is a first-class citizen on the network. That is one of the biggest things I think that distinguishes Kubernetes from other scheduling systems. And I started back in Beowulf clusters when we were doing, analysis of, all this collider data coming off. Right? That was MPI message passing. It was kind of the half-baked way of doing some of this stuff. But this is full-on every single microservice that I have. Right? And again, microservice is a little misleading. Microservice is not a container. Microservice is something that's first-class addressable on the network and that can communicate with other microservices that are also first-class addressed on the network. They all have IP addresses. Good, we got the basic definitions. See, I told you this would be easy. All right, so let's talk about workloads, right? So this is actually what we're driving toward. People who want to consider microservices as a container, well, then we're just going to introduce this abstraction of a workload, and we're just going to call this a pod if I'm doing Kubernetes. But none of you have legacy applications running in your companies, right? Capital One, right? No. Everything is containers, right? Everything's containerized. It just works, right? Yeah, that's how most companies are these days. They just flip a switch and boom, paradigm shift happens, right? Workloads are not just containers. They can be VMs. They can be physical bare metal machines. Anything that is what? First class addressable on the network. Okay. So we've gone through the different manifestations of what I'm considering a workload. So something that's interesting to look at when you look at the different ways that workloads are manifest, right? From a lifecycle perspective, bare metal tends to be pretty static, right? It's somewhat difficult to provision unless you've got some really fancy pixie boot stuff going on, right? Maybe you're Google and you wrote your own, Linux kernel to put in the UFI. There's all kinds of crazy things that you can do. But for the most, average person here, it's hard to set up a physical machine. I got to plug cables in, got to install an OS. Now I've got to partition drives. A lot of stuff to do here, which also means that I probably don't have very many of them typically, right? Which led to the development of the virtual machine, because virtual machine says, well, I can now make better, efficient use of the resources that I have. Oh, and by the way, I can spin these things up faster and tear them down as well. So now they're ephemeral, so I can use them for testing, or I can blow it away if something goes wrong and reestablish. I can snapshot it. All these wonderful features, right? So my life cycle is becoming more dynamic, and I have more virtual machines that are spread across these physical compute nodes. But the utopia is here's where you hear the nice awe sound from heaven above, right? We've got containers. I read an interesting article, by the way, as a side note, that they've got some VMs now that are booting faster than containers, some micro VMs, which we may see another paradigm shift happen if that continues. But let's don't go there yet. Let's stick with containers, okay? Let's keep this paradigm going. So containers, what is a container? What's the simplest definition of a container? Can somebody offer? What do you think? Abstraction layer, okay. Joe?
A process running on a separate namespace.
It's a process, right? I'll do my, yeah. A process, right? Oh, Microsoft fans. Okay.
Some libraries.
So yes, all a container is a process, right? What it means is that it is restricted. It has restrictions around a couple of things. It actually, containers use two things in the kernel. There's two primitives that control what a container is. You have control groups and you have namespaces. Now control groups, let's start with namespaces. Namespaces restrict what I can see. Okay, so let's take like a file system, right? If I've got a file system, if I want to restrict something, a namespace is going to restrict what files and directories and nodes that I see in that file system. If I'm talking about the network, a namespace is going to restrict what interfaces I see. Maybe I have my own copy of IP tables and things like that. Control groups, on the other hand, they restrict what resources I can use. So imagine with me, I've got 500 megs of memory, right? Where I use a control group or a namespace to tell my application I want it to use only 25 of those 500 megabytes. Control groups, right? I'm restraining the use of the resource. And this is really important because when we start spinning up lots of containers on a system, one of the best DDoS attacks, right, is spin up a container that uses all the resources. Well, guess what? None of the other containers should spin up, right? You're in trouble. Your cluster just came crashing down. So, containers, process that usually has an entry point that has namespaces and control groups around it that are constraining what it can see and what it can do. Who is familiar with this? The OSI network layers. This is kind of like anybody that's gone through computer science or had to debug any communication between two applications realizes that we try to create, this is not a perfect abstraction, okay, but this is a workable abstraction for us to at least talk about. There's a canon around it. People understand the terminology. What we basically say is that things that are up there at the top layer, I didn't put layers 8 and 9 up there. I'm going to put layers 8 and 9 up, right? Management, bureaucracy, right? We'll leave those off the chart for tonight. Okay? So starting at layer 7, okay, an application wants to talk to another application. Well, layer 7 is the most differentiated layer of all the layers, right? Because it's specific to an application. That application has some specific message that it wants to pass to another application. But that has to get translated down the stack through the other layers. Through the presentation layer, the session layer, the transport layer, which would be something like TCP or UDP or ICMP, right? As it moves down, we get down to the network layer. Now we're talking IP. And as it goes through each step, you get something that looks more and more consistent and uniform. And that then is what allows us to connect all these different networks together that are doing different things, different applications that are running, et cetera, because they're all talking a common language at the very, very bottom, right? So the most common, at the very, very bottom, is going to be your media and your physical layer, right? You're going to have things like Ethernet going on down there, sometimes the fiber connections, et cetera, right? So typically, when I want to talk between two applications, I travel down the stack on one side and up the stack on the other. Tonight, we're going to be talking about two projects, and I want you to understand where they fit on this stack. Basically, when you look at this stack, those that are more focused on operations traditionally have been focused towards the bottom of the stack, right? They want to make sure the network is running and doing the things it's supposed to do. They want to make sure that firewalls are in place and policies happening, and and nobody's spoofing MAC addresses, and somebody plugs into the socket, 802.x, 802.1x is running, and preventing their machine from connecting. All that kind of stuff happens towards the bottom of the stack. Whereas developers tend to be focused on the top of the stack, because that's where their applications are, right? Their applications live up there at the very top of the stack. What we've discovered is, just like in software development, when the Game before came out with this idea of design patterns, there's lots of patterns that are used over and over and over, whether it be software, whether it be doing operations. And so why do we keep reinventing those wheels? The most important thing for us to focus on, especially if IT is a secondary type function of our companies, we want to use IT to differentiate our company. We want to use IT to make us different, not to commoditize things we already have. And so this is just one other way that we can enhance how IT is going to help us differentiate what we do at our company. So Project Calico is focused at layers 3 and 4, the transport and network layers. So in Project Calico, we deal with things like routing. We deal with things like policy on IP packets, like firewalls. We traditionally think of firewall. At layers 4 and maybe 5 through 7 with Istio, we're actually forming service meshes. And so when you write a distributed application, you have patterns that repeat. For example, who in here, developers? How many developers do we have? Great. So who's ever written a database application or some application that connects to the database? And who's ever had that application start up and not be able to connect to the database and then core dump or just die? You see, that's an anti-pattern in distributed programming. Everything is declared in the distributed programming. You want, number one is there's no defined order at which and then it says when different parts are going to come up. The database may be the last thing that comes up, right? So if you're writing an application that's going to connect to a database, when it comes up, unless something else is just blowing up or its CPU's dead, it should just continue trying to connect to that database over and over and over. Now you might want to do some interesting things like put an exponential backup on it so that you don't completely kill the database and knock it down when it comes up because everybody's sitting there trying to hit it so hard, right? But it needs to be resilient. We should write things, like you were talking about Joe and the Chaos Monkey, we should write things in a way where we expect them to fail. Doing that is hard. Doing retries is actually hard. Netflix, again, who came up with Chaos Monkey, they also came up with the Netflix architecture, which was a set of tools to help us do these distributed patterns in a more uniform way. Things like retries, things like circuit breakers. Anybody use circuit breakers in here? Great. So when you have a lot of services that have a lot of interdependencies, and usually the way that you tell something is broken is how? Service A calls service B. How do you know it's broken? Not responding, right? Does that happen immediately? Just usually a timeout, right? Timeout of a couple milliseconds or whatever, but if that couple milliseconds timeout starts adding up and cascading to other services, right, you can have a major outage occur. And that's what a circuit breaker does, is as soon as it sees something that went bad, it basically flips the switch and says, anything else that tries to contact this, immediately return if this isn't available and go try somewhere else, right? Those types of patterns are not necessarily trivial. But we don't want our developers focusing on that. We want our developers focusing on the logic and the processes that make our company better. And so Istio is going to focus on how do I lift these patterns up into another layer. We're going to call it the service mesh, where applications don't even, in some cases, realize they're talking through this service mesh, and these patterns get implemented for them automatically, and can be configured by a group that is different than the development group. So the developers don't even have to worry about this. Things like authentication, right? How many times have you written an authentication pattern? I'm sick of writing authentication pattern, right? That problem's been solved. All right, but we write it over and over and over. Let's let Istio handle that. So let's start with Project Calico. Project Calico really fundamentally solves two problems. We solve the reachability problem, and we solve the policy problem. Let me explain. Reachability. Reachability is the service A talks to service B. They may be on the same host. They may be in the same container. They may be in different containers. They may be different containers on different hosts. We just want to make sure that our two services can talk to each other. We really don't have a distributed system that can talk to each other, right? That's the reachability problem. The policy problem says, is it okay for service A to talk to service B? And in what circumstances and contexts can service A talk to service B and vice versa, right? The reason that I put this slide up here is, in the past, we have conflated these two concerns to solve policy problems. We have used reachability concepts to solve policy problems. Bad. An example, I'm going to ask those who have dealt with firewalls and such. You have an organization that has an accounting department. They've got an ERP system. There's another organization that wants to tap into the data in that ERP system, but they're not on the accounting, or they're not part of the accounting group, right? Or maybe I don't even want that system to be able to see that there's an ERP system. How do I keep these things separate within a typical enterprise? What is it?
Domain boundaries.
Domain boundaries? Okay, and what primitives do I use to set up those domain boundaries?
Tracking tables and routing tables.
Okay. VLANs, maybe, right? We put things on different VLANs, and what do we put between the VLANs? Routers and firewalls, right? We put static barriers between those two things, right? And so what we've now done is we have induced a specific connectivity topology onto our network so that we could solve a policy problem. Because guess what? All the traffic now, unless you're doing something fancy like ACI or, which is really kind of weird, but we'll get into that. All of our connectivity problem, right, is now being forced through, if application A over here in accounting wants to talk to some other application somewhere else in the company B, I have to go through a hole that I poked and my static barrier between those two things on different VLANs. And so I can induce certain topologies that I may or may not want. One of the phenomenons that we're seeing is in data centers, when we talk about, I'm going to define east-west and north-south traffic. So if you hear the term east-west traffic, we mean within a data center, we have services that are talking to each other, okay? North-south traffic is, I've got somebody who's outside my data center, so a customer or something hits the company banking website or whatever, and then they basically flow down into the data center, and as their request, I don't know, whatever it may be, maybe they're paying their credit card statement or checking their bank account. All of the information from the microservices it takes to gather that information is east-west traffic, right? And then once the answer has been gathered and they're able to render the result for the user, it basically then goes to north-south traffic back to the user. We're seeing that east-west traffic is now the trend, is the leading traffic in the data center over north-south traffic, because we have a lot more microservices deployed, and we're doing a lot more collaboration with services, things like data analysis and big data stuff, and there's lots of reasons. But basically, the east-west traffic has grown considerably more than the north-south traffic. And so as we build our data centers, we want to adopt topologies that allow services to, from a physical path perspective, get to a service that they want to talk to as easily as possible. And hub and spoke patterns don't really work well, right? Which is what these static barriers using VLANs and firewalls are designed to align best to, right? The other problem with static barriers like firewalls is usually companies don't have one or two, they have multiple firewalls. There are two types of organizations in this world. There's organizations that know they've been penetrated, and organizations that don't know they've been penetrated. Simple as that. So to build a secure network, we have to start with a zero trust model. When I go into a company and I design a networking topology and policy program for them, I'm going in not trusting anything, right? The traditional idea was we're going to have this onion approach. We're going to set up an external edge for everything on the internet, bad. Everything on this side of the firewall inside the corporate network, good, right?
doesn't work. Okay, well they say, okay, well, what we'll do is we'll put another little internal firewall. So everything in the data center now, you know, if it's not on where all of our desktop machines are and stuff, that's okay. But if it's inside the data center, it's trusted, right? That doesn't work anymore. Well, okay, we'll move the firewall back, and you can see we're just continually creating these little perimeters. But the most secure thing that we can do is we can bookend security and say we're going to push the firewalls. This is microsegmentation, basically, right? We're going to push the firewalls all the way to the edges of each application that's talking to each other. So as soon as this application gets ready to put any type of bits on the network, it has to hit a firewall, and as soon as this application is to receive any bits on the network, it's got to hit a firewall. And if I push it all the way to the edge, right, and I don't care what's in between, I'm going to assume that I'm going to have secure communication in between, I'm going to encrypt the traffic, whatever it may be. If I push that all the way up to the edge, when I do get penetrated, because it's going to happen, I'm going to reduce my blast radius by a significant amount. And so that's the type of thing that we're advocating. Now, if you actually check out Google, they just came out with Beyond Corp. I don't know how many of you are following that, but they're actually proposing multiple white papers on rethinking the way they even do internal networking, right? They're basically getting rid of the entire concept of the VPN. The VPN doesn't make sense anymore. Even within Google buildings, when you connect, to a Google machine, it's going to treat that connection as an external connection. Now, it's going to do some two-factor authentication and other fancy stuff, but it treats everything as an external connection. Because it doesn't make sense to have VPNs because we know that the perimeter model is flawed anyway. So Project Calico is one mechanism and one tool set you can use in trying to get that zero trust model and start moving firewalls out as close as possible to the application. So that's the kind of the policy part of it that we're talking about. And we like to keep those two concerns separated because we think that they're two distinct problems to solve. And we don't want to mix and influence the topology of one thing, based on how we solve the other. We know this works. This is a shame plug for me. We're underneath Google, we're underneath Box, we're underneath IBM Linux, right? These are massive cycles of containers in flux every day, being spun up, spun down, policies being enforced, okay? So this is something that actually works at scale. When we built this, we looked at what was the largest example of a scaled network out there. Any ideas what that might be? What was that? The internet, of course, right? And so the underlying technologies we use are the underlying technologies that the internet operates on. And if it's good enough for the internet, it's good enough for us. So let's define some points. Start with endpoint. So we already kind of know what a workload is, right? The endpoint is the point at which a workload is going to either receive or put bits onto the network, right? We're basically defining it as the interface to the world. So let's look at a couple of different types of endpoints we have. So if I have a bare metal machine, remember that was one way to deploy workloads, right? We're not limiting ourselves just to containers. If I have a bare metal server, I'm assuming that I've got some physical hardware with a NIC that's connected to Ethernet, right? And it's running a Linux kernel on it. And that Linux kernel is going to expose that NIC as Ethernet 0, and an application can bind to it using a socket API, and it can start putting packets onto the network, right? And one of the limitations that we know about running multiple applications on a single bare metal machine is that you can't have multiple applications binding to the same port. Because why? They're sharing that port space, right? There's only so many ports. They all have one IP address, right? And so this model works, and it's actually applicable for some things, but it doesn't scale very well when we want to get a lot of elasticity in terms of workloads, right? So we move to the VM, right? Well, we start virtualizing some things. So we've got the hypervisor here. Hypervisor is virtualizing maybe some physical NICs. Project Calico really doesn't care about anything from the green down, really. We're really looking at where the OS network stack starts and going up from there, right? So it's a Linux kernel, right? So in this model here, the Linux kernel is a virtualized computer
And when you look at it that way, it really just looks like the previous model, right? So nothing really has changed here. We just happen to have more things, and the life cycle is different, right? So if we have something orchestrated VMs, we might want to listen to metadata coming out of the life cycle events of that, so that we can make sure and associate policies and reachability information as VMs come and go. So, for example, with like OpenStack, we have a plugin to OpenStack that does that very thing. And so then we move into, if it'll change, there it goes. Then we move into containers. Now here's where I'm going to start demystifying it. If you ever started to take a look at container networking, it kind of looks like magic if you don't pull away the covers and look what's happening inside. But it's not magic, really. And by the way, there are multiple. Okay, Calico is not the only networking solution for doing networking with containers. There are other solutions. I'm going to focus on Calico primitives tonight, but I just want you to be aware that there's other. I'll put it this way: there's more complicated ways to do it, and why would you want to do it more complicated when you can just keep it simple, stupid? But I'll let you discover that on your own. So with the container model, we have containers, right? Now, where it says container, and I've got that green box. What kernel primitive have I used to carve out what I can see? What is that now? The green box. We talked about 2 kernel primitives that help us build containers. What are they? Namespaces and? Exactly. So I've got a namespace now. That's how I can have an Ethernet 0 here and an Ethernet 0 here. All this is running on the same kernel, guys. Matter of fact, something as a side note you should be aware of when you're using containers. Kernels still matter, right? If you have something that's an application that depends on a specific kernel, and another application depends on something specific in another kernel version, and you try to run them in both the containers on the same kernel, you're going to have problems. Because ultimately, underneath the hood, they're still seeing the same kernel. It's just that this container here has a whole new network namespace. It has a copy of the forwarding information base, which is basically a routing table. It has a copy of IP tables. It has a copy of a lot of things. And a matter of fact, this Ethernet 0 here is not a real interface. It's a virtual interface. So what Calico does is it actually creates a virtual Ethernet pair. This is a special Linux primitive in the networking stack that basically says, you know what, we're going to put this virtual Ethernet wire in here. We're going to create a virtual interface inside this namespace for the container. We're going to create another virtual interface that's unnumbered down here in the kernel. We're going to give it a name. And we're basically going to say, when any packets hit the top one, they automatically flow down to the bottom one and vice versa, right? So these are connected together. But the 2 endpoints live in different namespaces. The bottom one, the Kali one here, which is a Calico interface, it lives in the root namespace, right? The domain 0 namespace of the kernel. The other one lives up in the containers namespace. And the mechanism that creates this is called the container networking interface. We have a plugin that implements the container networking interface. There was another CoreOS offshoot that basically said when container runtime engines want to create and do network plumbing, we ought to have some abstract interface that, because remember, there's other ways to do this, right? We ought to have some abstract interface that an orchestrator such as Kubernetes or DCOS and Mesos or OpenStack or something can call into, and then let whatever plugin I plugged in do the work and make the plumbing happen, right? And so Calico actually implements a CNI plugin, and when Calico is being used in a cluster to provide network reachability, we use that CNI plugin to provide the connectivity. So in some cases, it could be Flannel or it could be Calico. We actually maintain both of those projects that were heavy committers on Flannel. And whichever one you plug in is then going to define what types of primitives we see here that are connecting. You know, if I'm using Flannel, I'm going to see things like bridges or other things in there, right? Or if I'm using OBS, I'm going to see lots of bridges, lots of switches, virtual switches, and things going on here, right? But Calico is a strict layer 3 routing protocol. We're basically kicking layer 2 to the curb. We're saying we really don't need layer 2 anymore. Because that's how the internet works, right? When internet sites connect, right? You got Verizon's pop over here wants to connect to level 3 or AT&T or whatever, right? Pops don't go start ARPing the internet looking for connections. That would be insane, right? Talk about a broadcast storm. They have a protocol called BGP that gossips around between them all, right? And it basically advertises who's connected to who. So they don't need to ARP because it's not layer 2, right? It's predefined connections. So we're going to treat containers the same way. What this means is if you're doing something like Calico Network, if you really need the broadcast domain, you need to be able to send out a broadcast on layer 2. That's what Flannel is for. That's really expensive because when you think about the way the containers are implemented, you're going to be replicating Ethernet packets at the head end. And when you start replicating layer 2 things, it gets really expensive. And frankly, it's not going to scale to the size of some of these other clients, right? All right. So we have, we know now how the plumbing is set up for doing container. Let's look even deeper on the inside to see, okay, well, that's cool. I've got plumbing. I've got these Ethernet interfaces in here, but still I don't know how service A talks to service B. They're on different hosts. There are these different containers on different hosts, or they may move around, you know. For a little while, service A or pod A may be here, and it may die, and they come up on another host over here. So how does the host, the service over here or pod that wants to talk to it, how does it find it? Because it moves around. Containers are ephemeral, right? They're coming and going. I think it's long term. So let's figure out how we're going to do that. So let's imagine we have 2 hosts. Okay, I'm going to assume that I have some type of connectivity between those hosts. I don't care if it's layer 3, I don't care if it's layer 2. At the host level, I just know that host 1 can reach host 2. There are some subtleties here when you're working in Amazon with like availability zones and things like that, but we'll get into that here in a minute. All right, so let's spin up container A's, B, C, and D, spread them across the host like this. Now I'm going to introduce our friend etcd. etcd is a distributed key value database. It's just a database, okay? It just happens to be that the entire contents of the database are stored on multiple nodes, so if I pull out a shotgun and shoot any of those nodes, we're okay. We're going to still run. Again, we're in a distributed system, so let's use distributed things. So we start with etcd, and we need to capture information about what's going on. So if I want to do, if I want to create routes and I want for pods to be able to talk to each other, I've got to have some type of information about what pods are being scheduled where, and also maybe what their IP addresses are, right? Or otherwise I can't inform my hosts, which are now routers, by the way. Had an interesting conversation when the aha light bulb went off at a major manufacturer the other day, and we were talking about this, and he said, "Wait a second, every host is a router." And I said, "That's what I've been saying." So now he has this idea that he has an order of magnitude more routers in his network than he ever had before, and his mind just almost exploded, right? But that's a realization that you've got to come to now. Every host is a router. And so what I need is this metadata, this great metadata from Kubernetes. Remember we had events that Joe was talking about? Every time a container is created, destroyed, the CNI results come back, and it gets an IP address from the IPAM module and CNI, et cetera. All that information, that great information, can be captured by one of our plugins. We don't care what orchestrator it is. We have a limited set, but for the most part, right? We don't care if it's Kubernetes or OpenStack or Mesos, that type of thing. But we capture that metadata with a orchestrator-specific plugin. And then we canonicalize all that data, all that metadata coming in, and put it into our database, our etcd database. Now, we have a version coming out. It's actually already available. It's just not parity complete, but in the next couple of weeks here, we'll have a version hitting that. Instead of using etcd directly, we'll actually, like everything else, we're going to the Kubernetes API, right? Where we'll create custom resource definitions, forward to the Kubernetes API, which at the end of the day, it still hits etcd. You just put another abstraction in place, right? But it's a better way to do things because it's more compatible, and it can probably survive. It's easier to manage too, right? Managing multiple etcd databases and backups and all that kind of stuff. It's just a pain, right?
So eventually you probably want, if you're running Kubernetes, you want to go with the Kubernetes data store, which will be available. But either way, we're putting it into a database. We've captured all that metadata. We know where containers are, what IP addresses they have. Then we install an agent on every host. We call it Felix. By the way, another side note on the tigers and cats and kittens and all that fun stuff. So Project Calico was started by our founders who are either working or from the UK. And Calico is actually the simplest type of weave for Fabric, right? A 2x2 weave. And so they were saying, keep it simple, stupid in the way that we're going to interconnect from a reachability perspective, the new policy, right? So that's where the name came from. Unfortunately, 2x2 weaves don't market very well on the internet, right? So cats market much better, and so thus the Calico kitten was born, and we have our whole marketing and branding around the feline. All right, so Felix goes on every host, and it's a distributed control plane. What it's going to do is it's going to listen for changes in etcd that are specific to its host. So when it sees that, oh, container A is spun up on my machine, and oh, by the way, it has this IP address, it's going to write an entry into the kernel, a routing entry, and maybe some IP tables entries if there's policy applied, and tell the host here, this kernel, that any packets arriving at its front door that are destined for the IP address of one of its containers, that it should just forward them right along, right? The routing function. That's all it writes. So if it's writing the rules here for host 1 that says, when I receive packets bound for host A, forward them up here to A, or for B, forward them up here for B, how does C still know how to get to A, right? Because there's no direct path from C to A. C has to send his packets to host 2, which acts as a router, right? And then host 2 has to send his packets to host 1, and then ultimately host 1 has to forward it up. So how does host C know how to send packets to host A? BGP, bingo. So in comes BGP, the protocol that most people think is only for the internet, but is actually being used in data centers worldwide now because it's just so much more efficient. So we have BGP to the rescue. Now some of you that are watching really closely might say, but Cody, you already have a distributed database. You already know everything that's going on. Why do you need BGP to basically tell everything that's going on? Why can't host 2 just reach into etcd and say, well, you know what? I know what's on host 1 over here. And so I can write a route into host 2 that tells my containers how to get to container A. I'll just write a route in here that says anything bound for container A, use host 1 as a gateway. The reason is that when we would be reinventing BGP, which isn't a very good idea, number 1. Number 2 is, if we want our routing strategies to align as closely as possible to the physical topology, we need to be able to communicate to the underlying fabric. And most underlying fabrics, I don't care if you're using Cisco Fabric, or you're in AWS, or you're using name your favorite switch manufacturer, they support BGP because it's been around so long. So if we talk BGP and it talks BGP, guess what? Now we can actually offload some of the work down to the underlying fabric in terms of the routing. When we don't offload the work and we've got intermediate points between us, like in AWS, for example, right? When I want to send packets from one host, from a host in an availability zone A to a host in availability zone B, unfortunately, AWS's design doesn't allow me to peer with the intra-AZ router and advertise routes to it. So therefore, I have to do basically encapsulation on the fly. So we have modes that handle those situations. It can do like IP and IP on the fly, and we just and we optimize that, right? So if I'm communicating between 2 hosts in the same AZ, I turn it off because I don't want that encapsulation. It's just adding overhead. And when I have to communicate with hosts in another AZ, I turn it on. Just flip the switch. But I know where these IP pools are. So we have Bird, which is a great BGP agent installed. We have some other options too, right? It doesn't have to be Bird. We're tinkering with GoBGP right now. There's some other options out there. But basically, we need a BGP talker. We need somebody who is watching the kernel. Remember, Felix wrote into the kernel about host 1. He basically told host 1 how to get packets that arrive at its door bound for container A to container A. Well, Bird sees that route and he says, well, that's a cool route. All my peers need to know about that route, right? So I'm going to let everybody else know. I'm going to advertise that around. So the Bird over here says, oh, look at that route that host 1 just told me about. Well, guess what, container C? You can now talk to container A because guess what? I know is gateway. Gateway is host 1. So anything I see destined over here out of container C bound for container A, I'm going to say, well, send it to host 1. Host 1 will figure out how to get it the rest of the way there. And now I've done routing. And now you know how container networking works, and it's not that hard, really. Right? So underneath the hood, what's really happening is, as you see, Bird is looking at the forwarding information base, which is basically the routing table. And then Felix is modifying. So the way you think about it is routes that Bird is only writing routes for containers on other hosts, where Felix is writing routes for containers on the same host, right? So they're kind of doing inverse jobs there. And then finally, we have our own cuddle tool, Calico Cuddle, similar to Kube Cuddle, Istio Cuddle, name your favorite cuddle, right? You can cuddle my kitten if you sent that tweet. So hopefully you did that. But Calico Cuddle, all it does is it puts entries into etcd because guess what? Remember, we don't have a green field, right? We don't have a green field anymore. We still have that old rickety, MySQL database standalone by itself over there, that Apache, Tomcat server over here, that Memcached server, that Kafka server. Name your favorite standalone legacy thing that's sitting there. It needs to interact, excuse me, and routes need to be shared between my cluster and that service. And so I might, since all the information we've gotten so far has been from the orchestrator, I have other things in my network that aren't being orchestrated, right? So I need to manually tell Calico's networking infrastructure about those endpoints. I need to say, well, I've got a MySQL server. It's over here at this IP address. And I may even have a Felix agent installed on it so that it can implement policy locally. Again, I want to book in the policy as far as I can. But say it's running AIX or it's a mainframe or something, and it doesn't support the Felix agent yet. Okay? Well, I can at least do kind of a half duplex or a halfway policy, right? So I can at least implement egress and ingress on one side of the connection to that external service, right? But I still need to inform Calico and the other internal networking components about that. So policy, what is policy and how do we do that? So we've solved the reachability problem, right? We know how to get packets around between containers. Well, now we want to restrain what they can do, right? We don't want the accounting application talking to anybody who just connects to it and decides to, list accounts payable, right? We want to restrict, who has access to that API. We do that with policies, and you'll see the word profile up here. Profiles and policies are almost interchangeable, but they're targeting different things. So they have similar semantics internally in terms of specifying rules on, for example, rules like, you can connect on this TCP port or that, UDP port, or you can receive information, or you can get it from this source, that source. But profiles traditionally target static host endpoints, where policies are more dynamic, right? And they're just in time rendered because remember, these things are changing all the time, right? What IP address does. We don't use IP addresses as an identifier. That's a bad thing, right? So when things were static, a lot of times, like you think of old firewall rules, we would use IP addresses as the mechanism to identify what we were talking about blocking or letting through. And now that IP addresses are ephemeral and they come and go based on where the workload's getting scheduled at, we don't do that anymore. I left out one piece I just wanted to briefly mention to you. So you might be asking, well, when the CNI spins up these containers, how does it know what IP address to give it? In Kubernetes, there's 3 different network types, right? There's 3 different networks that we use. We have a host network. That's the network from which, and when I say networks, I'm really talking about sitters, right? They could all be on the same network. I don't really care.
I just want to know what like range of IP addresses I can assign. So the hosts are assigned from one range. The pods are assigned from another range. And then if I'm doing something with Kubernetes services and using kubeproxy, those get assigned from another range. And those are virtual IP addresses, right? They're not really, kind of like the spoon in the matrix, it's not really there, right? It's synthetic. Just like the pod is synthetic, it's not really there. It's just an abstraction that Kubernetes creates around containers. So in this model, the way that we get IP addresses, if Calico is doing reachability and the layer 3 stuff, we actually have a pool set up, and the first time a container comes up on this host, it says, oh, I got a container, I need to give it an IP address. So it reaches into the database, and it grabs the first /26 that it sees. It grabs the /26 sitter, pulls it over, and then it starts assigning IP addresses out of that /26 until it exhausts it, and if it needs to go get another one, it goes and gets another one. And it may not be contiguous. It may be from another one, there may have been 3 or 4 other hosts that have already grabbed the next /26, right? But it just keeps grabbing /26s. And if you did poor planning and you exhaust those /26s on one host or something like that, we can do scavenging and go we can grab /32s from other /26s. You just have a lot more routes that end up showing in your BGP tables, because now instead of being able to summarize at each host on /26s, I've got /32s intermixed, and again, the longest route wins. Just basic routing rules. Now this is being stubborn here. So we talked a little bit about profiles being assigned to static endpoints, and then policies taking precedence, by the way, over profiles and getting rendered dynamically, right? Kind of a just-in-time rendering of a policy, making sure that it matches labels. One of the pieces of metadata that we pull down from orchestrators like Kubernetes is, we know in Kubernetes labels are how we do a lot of things, right? We use labels to select what pods are back in the service, and how pods might get assigned to nodes. All these things are very important for us, right? Labels describe the management dimensions that we're using for these policies. And it's not hierarchical, right? It's very flexible, right? Because it's a multiple dimensions that are available. But we pull all of those labels down into Calico. And Calico has its own concept of labels. So usually the way that it works is all the labels in Kubernetes end up in Calico, but you can create additional labels in Calico that you can assign to workloads that are not in Kubernetes, right? So Calico could end up having more labels than what's up in Kubernetes if I manually create those labels. I can do that in things like profiles. I can say, I'm going to profile this static endpoint, this host endpoint out here, and I'm going to basically say it's to synthesize and make it look like it has these labels. And so when I assign those labels in Kubernetes, right, things start matching up, even to the things that are not in Kubernetes where the labels got originally assigned. Additionally, what we can do is, in terms of policy, right, so everything I'm talking about here, this is using the Calico toolset to actually implement the policy. But the Kubernetes network policy was modeled after our policies. And so if you want, you can use the Kubernetes network policies, ingress and egress policies, within Kubernetes, and those also get pulled down and converted into Calico policies. If you want the most fine-grained control, you don't get all of the features in just the raw Kubernetes policies. You have to use a Calico policy, but they are very compatible. So an example policy might look like something like this. So guess what? It looks like Kubernetes, right? I have an API version, I have a kind, it's a policy, I gave it a name. This is the most important thing though, right here, this little selector, it's gonna select. The selector here basically says, who does this policy apply to? I'm saying, apply this policy to any workload, any pod that has a label on it called, with a key role in the value database. Then I can say things like, well, you know what, I want to allow TCP ingress from any other workload that has the label key role value front end. Now again, that workload doesn't have to be something that got scheduled in Kubernetes. It may be that MySQL database out there that I manually informed Calico that it had an endpoint and it had the label front end maybe, or back end, or whatever it may be, right? So it's really flexible in that sense. And then I can also assign egress. It used to be before Kubernetes 1.8. If you're using like OpenShift or whatever, where it's like 1.6, so it's moving towards 1.7.
if you want egress, you got to go down to the Calico level, right? Instead of doing the Kubernetes network policy, because it's just not supported yet. But 1A supports egress, and it doesn't support it perfectly, but we're getting there. So we've kind of gone along the stack. Everybody clear kind of what Calico does? Let's take a quick look at Istio. How am I doing on time? I know we're running a little late, so how many minutes? Just be honest with me. Okay. All right. Is that okay with everyone? So Istio. So everything we've done is layer 3 or 4, right? When I get up into the application layers 5 through 7, I get a lot more rich data about what's going on, right? Down here, I can write policies at 3 and 4 that tell me to block TCP ports and to block certain protocols, and maybe only TCP and not ICMP or not UDP, those types of things. But I have no idea what's going on underneath the hood, because remember, as we go down the stack, we become more uniform, right? So we can pass the stuff around between the networks. As we go up the stack, it's more diversified, right? I can look inside of HTTP and I can say, well, maybe I want to write policies that say, based on a bearer token header or some type of user session that guy said, I want to limit what HTTP verbs you want to use, like get, or put, or patch, or delete, right? And I can write those types of policies. That's what Istio is going to allow me to do. So basically, if we look at a review, right, we've talked about CNI, we've talked about network policies, briefly touched on services. I'm not going to get into that. If you want to know how proxy works underneath the hood, come talk to me afterwards. We'll talk a little bit about ingress and about kubeDNS. DNS is really just a mapping between the metadata in Kubernetes on what IP addresses pods have, and it basically overlays the DNS system on top of that. So nothing really new there. Ingress is where we're talking about the difference between a proxy or a router that's forwarding packets versus a router that's actually doing application proxy. And we haven't talked about that yet either. So let's get into those topics. So Istio really solves 3 problems at layers 5 through 7 for us. If you want to boil it down, right? We solved the traffic management problem, all those patterns that we talked about in distributed computing, the retries and the circuit breakers, quota management, right? So anybody in here do rate limiting on an API, right? Those types of things, right? That can all be solved up here with traffic management. We do observability. Who's tried to trace a distributed program before? Right? It hops through 20 different services before it actually gets to the endpoint, right? Have you ever tried to figure out how it does that? Well, one of the things we have to do is annotate each step along the way and basically build up a span as it goes from one service to another, so we can actually see where the call is breaking down, where are we getting latency from, or where are we getting a timeout from, it's having to repeat itself, et cetera. That's what observability gives us. And then finally, security. And one of the cool things that they're doing here is we're using Spiffy to do mutual TLS between services. So we're using things like the service account and various Kubernetes identity primitives for services to prove, as they're talking to each other, that they are who they say they are via TLS, and automatically creating a TLS encryption, right? I bet most people in here are working in environments where you can't have data unencrypted at rest, and you can't have data unencrypted in transport either. And so these are the things that are going to help us solve these problems. So from a traffic management perspective, I mentioned some of these, right? We can do canary deployments. Kubernetes out of the box can do a canary type deployment, but it's really raw. That's the idea of a rolling deployment. This allows us to do a lot more fancy things, right? Maybe base it on a specific user population or base it on other types of metrics that we're measuring. I can do blue-green, it's kind of the same thing. I can do load balancing, do multi-tenant concepts. I can even plug in special protocols like MongoDB protocols, and you figure out how it's sharding data, and actually maybe do some of the shard routing in this layer here, right? Which is really cool from a data management perspective, like for big data. Circuit breaking, timeouts, etc. On the observability, we mentioned tracing. I can do custom telemetry. One of the cool things that I can do is actually output everything that's happening at these layers to Prometheus. Anybody using Prometheus in here? Good, a couple users. If you haven't checked it out, it's a really cool project. So it basically allows you to collect all kinds of metrics in real time. It's a very generic system that handles counters, and histograms, and meters, and other types of metric gathering primitives, and basically allows you to send data to it. So Istio can send data to Prometheus as an example.
And then we can do logging, right? This is the, maybe I want to send stuff to the F stack or the ELK stack. I don't know. We use Elastic Fluent. You can use Elastic Logstash. It doesn't matter. You can send it, though, all the stuff that you're logging in this layer via that. And then from the security side, we can do identity, authentication, authorization, implement various policies, like what services can talk to what services based on more detailed information. I'm going to shortcut us to the end, right? I'm not going to get into the whole control framework and stuff. Maybe that's a second talk. Maybe I'm going to come back and we'll do another talk. But I want to emphasize, one of the questions you may have at this point, you're seeing, well, I'm seeing some things repeated here. Layers 5 through 7 and layers 3 and 4, right? Like, why do I have policy management at layers 5 through 7 and policy management at layers 3 through 4? Let me back up here and just show you one quick thing, and we'll close it with this. Okay, let's take a look at all the way back to here, this slide. How many of you use containers that are coming from Docker Hub or Quay? And I bet every one of you are scanning those containers with Twistlock or Claire or something like that, right? That's right. You know everything in those containers, all the CVE, zero-day exploits, right? We really don't know everything that's running in our containers. It's really scary, right? We don't know where we get zero day. But the cool thing is that we're running it in a container. So if something bad goes wrong, and by the way, just because you're running in containers doesn't mean it's secure. You need to put some other things on your host. SE Linux, AppArmor, talk to me about it. We can discuss that Kubernetes supports all these things. It has hooks for all these things. That's the wonderful part about it. But you need to make sure your host is secure. If somebody roots your host, tough cookies. You've got bigger problems in my Calico policy, right? But let's say that somehow a container gets out in the wild, didn't get scanned, or a CVE came along, it got rooted, something exploded, right? A contained blast. Istio, the way that it works is it actually installs, for doing policy at layers 5 through 7, it installs a sidecar into this container. Remember, that container has its own network namespace. So it has its own copy of IP tables, and it has its own copy of the routing porting information base, right? We want our applications to not even really know the service mesh is there for the most part. We have to know that it's there right now for tracing, because we have to copy headers from one side to the other. There's some other special use cases, but for the most part, we don't want it to really realize that it's there. So we want, service A to be, or pod A to happily think it's talking to pod C, and there's nothing in between, right? It just magic happens. And traffic gets encrypted and things get retried. The only way we can do that, though, is we have to write these special IP tables rules, firewall rules, into the container itself. And that's done with the Istio sidecar, and then what ends up happening is all traffic then gets automatically redirected to that sidecar. The sidecar acts as an application proxy. It's using Envoy, which has been proven out at Lyft. And there's basically 2 Envoy sidecars that are actually doing the long, part of the communication between the 2 pods. And then so pod A communicates, says, I want to send traffic to pod B. Well, what ends up happening is that traffic is redirected via IP tables to the sidecar. The sidecar connects to the sidecar over here, and then via IP tables, it naturally shows back up in the port that B over here was expecting. But all that happens, right? Well, what happens when that pod gets rooted? And, well, I have all this policy implemented as part of that IP table stuff magic that's happening there too. Well, whoever rooted that container can go in and change those policies. So if I'm only relying on policies up here in the container, I'm hosed. What am I going to do, right? I've already been cracked. So what I want to do is I want to have a stopgap, right? Security in depth. Let's put policy down here in our kernel. We know that our domain 0 namespace on the kernel is probably secure. So I put policy down here. And I'm not going to attach it to this end of the endpoint. I'm going to attach it to this end, because guess where this end sits? What namespace is it in? So if somebody roots this namespace up here, and I've got SE Linux and other things set up right, I'm not going to be able to jack with what's going on in these IP tables and in these routing rules down here at layer 3. So I can at least somewhat prevent the dam from breaking, right, by putting another stopgap underneath it, layers 3 and 4. And so what we're working on right now is we're trying to say, well, I really don't want to have to write that policy over and over, because if I write a policy that says this service can't talk to this service, there's all the HTTP primitives, right? That probably should imply, or maybe these services can, only these services can, that should probably imply that these two services can talk on HTTP ports together, right? Or something like that, right down here. Right? So if I'm already writing a policy up here at this top layer, it should imply the lower level stuff. So one of the things where we're actually heavily involved in the Istio project as well as the Calico project, because we want to make it easier to write unified policies that basically span the entire stack and do it in an intelligent way, right? So that's in a nutshell what's happening. I think Istio is one of those things that is going to really live up to the promises that it's touting right now. It's actually going to change the way developers develop code because they're not going to have to repeat themselves all the time anymore. Developers patterns, hopefully. Okay. I'm going to stop here. Open up the room for questions.
We started with Lano layering in Calico for network policies.
Sure.
But we don't do anything in layer 2 that really requires Lano. What is our? Is there a nutshell version of our migration path to full Calico stack? Is Calico supportive of continuing to run Flannel, and there's not really a concern there? What would you say are?
Number one, we're the largest contributors to the Flannel project right now. I mean, we basically maintain it by a proxy with CoreOS, right? If you still have things that applications, see this really actually comes down to what your applications require. If they don't require the broadcast domain and you really want to scale, you should migrate to Calico because you're going to have the pure layer 3 advantage there. So yeah, we can talk about, offline or whatever, how we want to do that migration, but it's definitely doable.
Insight into why egress was left out.
Just had a lot of stuff to work on. So, yeah, just insight for those that are new to Kubernetes. Kubernetes is the largest project, or the most contributed to project on GitHub. It's the most active project on GitHub. It has the most reviews, the most comments, far above all the other projects. And what that also means is that it's moving at a breakneck speed. And just keeping up with all the changes is nearly impossible. So, I think it's probably just a matter of if everything's priority, that's priority. Other questions?
What about ACM?
So obviously they're a competitor, right? And they have a very new product out. Talk to me offline about that. I can kind of give you some insight on what's going on here. We have lots of competitors, and what we're finding out is when it comes down to this, we see Project Calico being used. If you look at the combination of Project Calico and Flannel, we're looking anywhere from 70 to 80% of install base in Kubernetes worldwide. And it's proven, it's been around a long time, and they have a lot of optimizations built in. I didn't get into all the details of how we select, do our IP tables match to our policies and all that stuff. There's a lot of optimizations in it. Go ahead.
So since we're using BGP for routing, essentially, does that mean that I can take all my old crusty BGP monitoring and management tools out of my data center and plug them in and have them watch my Kubernetes cluster and do something useful?
To some degree, probably. What it does mean, so if I'm using BGP to interact with Fabric, right, so that my topology can align so that I can have good alignment of my pod routing or my container routing to the underlying fabric. What it does mean is I need to, in some cases, for example, depending on my scale, I may need to optimize the way that I'm advertising those routes so that I don't have, I can have maybe all of the routes in every single router at top of rack, or maybe I only want to do things where I push down only default. There's different ways I can set up my ASs and various things like that. So that knowledge is very, very useful for that. Things like knowing, putting in filtering and stuff, like, when I'm thinking about top of rack and cross network designs, I want certain routes advertised across spines, but I don't want it advertised maybe up to the edge spine or out, right? So I've got to have BGP filtering in place, policies, and that kind of thing.
That was going to be my next question.
So yeah, absolutely. I mean, those things come into play, and so there's no free lunch. right? At the end of the day, you're going to have to, if you're building a network that large and it needs to be optimized, there's no free lunch. But the nice thing is we're using just standard ways of doing things. And so when it comes to implementing a BGP filter, or maybe I want to do anycast, maybe I'm tired about using load balancers in my network, right? Well, there's a little nifty thing you can do with BGP where you can say, I'm going to carve out a VIP, similar to the way kubeproxy does it, but implement it differently. I'm going to say, I've got this IP address. When I hit this IP address, I want it to be anycast, which means that if somebody calls this IP address, I don't care if it hits that server, that server, that server, that server, that server. Any one of those can respond to the request, and I can route around them. And so one way you can do that is with BGP and another little thing called equal class multi-path routing, which basically then turns on, if you want to think about stateless load balancing without actually having to have a load balancer. All your load balancing is actually being done by the network itself, not an appliance, which is really cool. We'll talk about how that works after this.
You mentioned elliptically some of the tunneling that was being done for across AZ. If you have a cluster deployed across AZ, what kind of extra guidelines do you have for setting that up? Is it exclusive? You have to be explicit about which nodes are deployed in which AZ?
Yeah. You have to define the pools and make sure cross subnet is set up, and so that it knows where those boundaries are, those kinds of things, so that it can automatically turn on IP and IP.
Okay.
I mean, you can do some naive things if you don't want to set those things up. You can say, I'm always going to use IP and IP, and it just always turns it on, right? Which is kind of how it works by default in some cases, right? Or it can turn it off or do cross subnet, where it does basically a calculation to figure out who am I communicating at the host level, so I know whether or not I need to turn that on. So
is there any reverse of that, where you have placement groups that are operating in a high-performance network scenario? Is somehow Calico aware of that, or
it probably could be made aware of that, yeah.
I'm working on a project, and there was a demand for supporting multi-tenant cluster.
Okay.
Multiple APIs, different namespaces.
Okay.
And I'm looking to use Istio Calico. So the question is, there an example or guidelines so that we can build good implementation for that to follow?
There are. Talk to me afterwards. I know it's late. You guys have been really patient sitting through all of this. I hope that it was useful to you. I'll throw up one last plug up here. Little clicker's not going to do what I want it to very easily. Go here to the very end of this. If you want to know more, we do have hands-on training classes. Most importantly, a majority part of my role is developer evangelism and help you guys out. So if you can just hit me up at Twitter or on the Project Calico Slack, if you're interested in what's going on, you can join the Slack. We've got a new Istio training class. We're also, I hope you're coming to KubeCon. We've got some really cool demos that are going to be going on at KubeCon. You're not going to want to miss. So other than that, that's the end of what I've got tonight. And thanks to our host for putting this together. I really enjoyed it and the interaction. I hope it was useful for you.